In this video, we're going to look at the vector between 2 points. Previously, we learned how to look at the vector that starts from the origin. So if a vector went to the point 1, 2, let's call this point A, and this is vector A, then we knew that vector A in component form would be, 1, 2. But what if the vector doesn't start from the origin? Let's say there were another point here. This is point B, and let's say point B is at 4, 1. And we want to calculate this vector. Let's say this is vector C. How can we find vector C? Well, since vector C doesn't start from the origin, it starts from point A, we can't simply, just take the coordinates. But instead, let's say, first, let's say this is vector B. And since vector B does start from the origin, we can say that vector B is equal to 4, 1. Now, if you remember back, what is the actual definition of vector C here? Well, vector C pretty much tells us we're starting from point A and we're trying to get to point B. But since none of these points start from the origin, we'll have to find another way. So another path from getting from A to B is to go this way. And what this is, pretty much first, we're going to have to go from A to the origin, which is negative A, because A goes from origin to A, and we're trying to go from A to origin, which is the opposite direction. So vector C is equal to negative vector A, and now we're here. And then to get from the origin to B, that's just vector B, so that's plus vector B. So vector C, or if you want to think about it another way, getting from A to B, you can do the opposite direction of vector A plus vector B. And this will simply, we can first rewrite this as vector B minus vector A, which will be 4 minus 1 and 1 minus 2, which is equal to 3, negative 1. So vector C, or the vector between points A and B, is equal to 3, negative 1. Now, let's look at an example question. Let's say we have 3 points. We have point A, this is 2, 4, and we have another point B, this is 4, 1, and let's say we have another point here that's not at the origin, and this is, say, point 1, 1, and this is point C. Together, these points form a triangle. But how do we find the perimeter of this triangle? Well, first of all, we need to find the vectors between for each side. So let's say this is vector AB, this will be vector BC, and this is vector AC. And using what we previously learned over here, we can say that vector AB is equal to vector B minus vector A. And from the origin, we know point B from the origin will be 4, 1, and point A from the origin will be 2, 4. So pretty much vector AB will be equal to 4 minus 2 and 1 minus 4. And this will be equal to 2, negative 3. So now we know the vector for AB is 2, negative 3. Next, let's look at vector BC. BC is equal to vector C minus vector B. And this will be, and since the individual vector c starts from the origin, we can say that this will simply be 1, which is the x value of c, minus the x value of b, which is 4, and then 1 minus 1. So this will be negative 3, 0. And then let's look at vector AC as our final side of the triangle. And this will be vector C minus vector A. And this will be 1, 1, which vector C is 1, 1, minus vector A, which is 2, 4. So vector AC is simply negative 1, negative 3. Now, we found vector AB, BC, and AC. So now what we need to do to find the perimeter is to look at the magnitude of each of these vectors. So first, the absolute value of vector AB is, well, here we know vector AB is 2, negative 3, so it's square root 2 squared plus negative 3 squared, which is equal to square root 13. And then the magnitude of, let's look at BC, is, well, BC is negative 3, 0. So this is simply a square root negative 3 squared, which is equal to 3. And then finally, look at the magnitude of AC. The vector AC is negative 1, negative 3. So that magnitude will be negative 1 squared plus negative 3 squared, which is simply square root 10. So now to find the perimeter, we simply add up the 3 lengths of each side, and this will give us square root 13 plus 3 plus square root 10. And this will be the perimeter of the triangle.